Hi, in our last session we discussed about the statistics and why you need to study business statistics in your MBA program and the branches of statistics, its application and the basic measurement level and some of the basic terminologies to understand the statistics subject. In this session, let us talk about what is raw data and how we can group raw data into raw data to get more information about data. Okay. Raw data are the data that have not been summarized in any way are referred to as raw data. Raw data, that is what we collect from the field. So, it is not been summarized in any way. This is called raw data, and then this raw data is ungrouped data. This is ungrouped data. So, this is raw data and it is not been arranged in any way except this is in the table. Even though it is in the table form, you cannot take any meaning, get any understanding out of this one. This is called raw data. The data that have been organized into frequency distribution. This frequency distribution is based on the occurrence of the data, how data points. Based on the frequency distribution is called the group data. And let us see how we can group this raw data. Okay. The distinction between group data and the ungrouped data is important because the calculation differs between the two types of data. Okay. The next is the frequency distribution. So, we can group data using this frequency distribution. Frequency distribution is one of the tools for grouping the data. Frequency distribution is a summary of data presented in the form of class intervals and frequencies. Let us see how we can construct the frequency distribution. There are certain steps we need to follow. First, let me explain what are all those steps in detail, and finally we can take one problem and then solve this problem and then construct a frequency distribution out of this raw data, and you will get to know. So, some of the you have to use the following steps to construct frequency distribution table. First, when the raw data is given, you need to determine the range of the raw data. Step 1 is you need to determine the range of raw data. Second step is, once you have determined the range of the raw data, you need to determine the number of classes. Determine number of classes. Number of classes means, let us see how we can group this data based on certain arrangements. Okay. After the number of classes, we need to determine the class width. Class widths. The next step is determine the class endpoints. Once the class width is taken, you need to determine class endpoints, and the last step is determine the class midpoint. Determine the class midpoint. So, if you follow these steps, you can reasonably construct a good frequency distribution table. Okay? Let us go one by one. When constructing a frequency distribution, the business researcher must first determine the range of the raw data. The range is defined. What do you mean by range? The range is defined as the difference between the largest and smallest number in the raw data set. This is called the data set. That is the range. The second step here is in constructing the frequency distribution table is to determine how many classes it will contain. So, how many classes you need to take? So, there is one thumb rule. You need to select anywhere between 5 to 15 classes. This is the thumb rule. So, if the frequency distribution contains, why only between 5 and 15? If the frequency distribution contains too many classes, the data summary may be too general to be useful. If you have too many classes, it's too few classes, it is too general to be useful. On the other hand, if you have too many classes, maybe the frequency distribution that does not aggregate the data so that you can get some useful meaning out of that one. That is why we have to take the reasonable number based on the number of elements in the data set. We need to choose between 5 and 15. The final number of the class is arbitrary. Arbitrary in the sense you need to do little bit of trial and error to fix the width of the to select the number of classes so that you can derive some meaningful information out of this. The business researcher arrive at a number by examining the range and determining the number of classes that will span the range adequately and also meaningful to the user. Okay? After selecting the number of classes, the business researcher must determine the width of the class interval. The class width, how do we calculate the class width? The class width can be calculated by dividing the range by the number of classes. First, we have seen the range and then number of classes. The class width is the range divided by the number of classes. The frequency distribution, once we have decided about the number of classes, the frequency distribution must start at a value equal to or lower than the lowest number of the ungrouped data. From where we have to start this grouping? So, we need to select a value equal to or lower than the lowest number of the ungrouped data, and the end point is the value equal to the higher than the highest number in the raw data set. Okay? And then class midpoints are selected. So, the class endpoints. So, how do we select the class endpoints? Because if there are some 5 classes, how do we select the class endpoints? We need to select the class endpoint so that no value of the data can fit into more than one classes. So, it means it should not overlap each other. Okay? And then finally, we have to determine the midpoint. The midpoint of each class interval is called the class midpoint. Sometimes it is referred to as class marks. So, this value is the halfway across the class interval. So, class midpoint can be calculated as the average of the 2 class endpoints. Okay? The class midpoint is important because it becomes the representative value of each class interval. Okay? And this is about the steps in constructing the frequency distribution table. Okay? First, once the raw data is given, you need to determine the range of the raw data. Second, determine the number of classes. Third one, you have to determine the class width, means this one and divided by this one, second step. And once the class width taken, you have to determine the class endpoints. This is also called class limits. And once that limit is class limits or class endpoints are determined, you need to determine the class midpoint. Why it is midpoint? Midpoint is a representative of this class interval. Okay, this is how you can construct an initial frequency distribution. And then after constructing the initial frequency distribution, you can put 2 columns in the table. One is for the relative frequency, another one is the cumulative frequency. When solving the problem, once again I will explain you clearly how to do that one. With this data set, how can we construct the frequency distribution, how we can calculate relative frequency, and another term we use is cumulative frequency. Okay, let us see what is relative frequency? Relative frequency is the portion of the total frequency that is in any given class interval. So, in a frequency distribution table, the relative frequency is the individual class frequency divided by the total frequency. Okay. So, let us see what it is. And the cumulative frequency is the running total of frequencies through the classes of a frequency distribution. The cumulative frequency of each class interval is the frequency for that class interval added to the preceding cumulative total. Okay. So, for example, the cumulative frequency for the first class interval is same as the class frequency, and the cumulative frequency for the second class interval is the frequency of the class interval plus the frequency of the first class interval. Okay. This process continues throughout the last class interval. For the last class interval, the cumulative frequency equals the sum of all frequencies. Okay. So, this is about some of the terminologies we used, these two, the common terminologies we use with the frequency distribution table. And in order to represent the frequency distribution, so one of the most widely used graph is histogram. Once we are done with the construction of the frequency distribution table, let us see how we can construct the histogram. Okay. So, understood? Can we move on constructing the frequency distribution? Okay. Okay. Now, let us construct a frequency distribution out of this raw data. Here is the raw data what we have explained. This data is about the number of days. There is a time taken to complete the year end audit for 20 clients. The number of items is a 20 number. 20 clients are there for an audit firm, and then is a year end audit they have conducted, and the time taken to complete the year end audit with 20 clients. This is what the raw data it says, and they have just put it in like this. You cannot derive any meaning out of that one. Okay. Now, the frequency distribution, what are the elements? So, how we can group this data? The first column is the how we can group this data. The second column, within that group, how frequently that the data points occurs, and the third this one is a class midpoint. This is the representative of this particular class interval, and the another two terms that I explained is the relative frequency and the cumulative frequency. Okay. What is the first point? So, there are two elements, n number of elements, 20 elements. Okay. What is the first point? First point, we need to determine the range of the raw data. So, what do you mean by range? Range is nothing but the difference between the largest value and the smallest value of the data points. So, how do we identify the smallest and the largest value of this one? We need to, so let us have a simple thing. Okay, when you have this, first in the upper column, let us say smallest number for the each column, and the here let us say largest number of this in this particular column, let us write. Okay. So, first one. So, what is the smallest number here? The smallest number is 13. So, what is the smallest number here? The smallest number here is 12. So, what is the smallest number here? The smallest number here is 14. Okay. And what is smallest number here? The smallest number is 16. So, now let us see what is the largest number. What is the largest number here? The largest number here is 28. What is the largest number here? The largest number here is 22. Here what is the largest number? Here the largest number is 27, and what is the largest number here? The largest number is 33. Okay. So, what is the smallest? Because we need to take the difference between the largest and the smallest. What is the smallest among this is 12. What is the largest among this is 33. 33. this is the largest and then smallest. So what is the range now? So the range is, so this largest number, 33 minus, and this is the smallest number is 12, the largest number and then smallest number. Okay, this is the range. This is range. What is this number? This number is 21. Right? This number is 21. Okay. So now we got the range. Now the next point is we need to determine the number of classes. So what's the rule? We need to select the number of classes anywhere between 5 and 15. How do you decide? So now the number of elements are 20. 20 is a small number. Any number which is more than 30 is considered as a big number. So 20 is a small number. For the 20 number of this 20 elements of this raw data, let us have this, let us select 5 as the 5 number of classes. We can select this one. So how do you determine, okay, number of classes 5? Okay, let us say number of classes 5, range is 21. Okay. So next thing, we need to determine the class width. What is the rule for determining the class width? Class width means range divided by number of classes is equal to 21 divided by 5. 21 divided by 5. This is 4.2 something it will come. 4.2 something, 4.2 days something it will come. And you need to approximate for round figure. Let us say this is equal to 5. Okay. This 4.2 we round it off to 5 days. Okay, got the idea? So that is, let us take the class width, the 5 days class width we can take. Okay. So next what we have to do, we have to select the starting point and the ending point of this group. The starting point should be lower than or equal to the lower than equal to the minimum number in the data set. Okay. The ending point should be larger than or equal to the maximum number in the data set. Okay. So in such a way we have to select this one. Let us select the lowest number is 10. Let us select 10 to 14. 10 to 14 is one group. Okay. 10 is not there, it starts with 12. So 12 is anyway between, so 10 and 14. Next 15 to 19. 15 to 19, because 5 days we need to increase the class width is equal to this much. Okay, including this, including the last number. Okay, 10, 10, 11, 13, 14, 15. 5 elements are there. 15 to 19, and then 20 to 24, and 25 to 29, 25 to 29, and then 30 to 34. 34. Okay. So the largest number is 33, and we have selected 34 is equal to 33 or larger than 33, so that all class interval should be equal. The class width should be equal. 5 days, 5 days, 5 days, 5 days. Got the idea? How to construct this number of, how to take the number of classes, and how to decide about the class width, how to decide about the lowest point and the end starting point and then end point of this grouping. Okay, this is how, this is the first step. The next thing, you need to count how many occurrences are there, how many numbers are there between 10 to 14, how many occurrences are there? Between 10 to 14, now you count how many numbers are there here. I'll write because it is solved, so you can take select and then you can put it. There are from 10 to 14, there are 4 numbers are there in this group particularly. Okay, and then between 15 to 19, there are 8 numbers. Okay, and then between 20 to 24, there are 5 numbers. From this raw data group, how many numbers are there between these? From this raw data group. Okay, and then from 25 to 29, there are only 2 items, and between 30 to 34, there is only 1 item. Number of occurrences for each group, each class. Okay, got the idea? Between 10 and 14, including 14, between 15 and 19, including 19. Okay, between 20. Why 19 including 19? Because see, you have selected the class in such a way that this is not overlapping with this. Okay, after 14, it starts with 15. Okay, this is how you have to do, or else in some of the table you can observe it is 14 and once again it will starts with the 14. At that time is 10 under 14. The last number is excluded. Let us deal with that case when it comes to solve the problem. Okay, so then the frequency distribution we have done. So next is the class midpoint we have to locate. So what is the midpoint? How do we locate the midpoint? Midpoint is nothing but this is the lower limit of the class, and it is the upper limit of the class. The average of these two numbers is the midpoint. So what is the midpoint? Average of these two numbers is 12. That is 10 plus 14 is 24, and the 12 divided by 2 is the average is divided by 2, and for second it is the 17. This 12 is the halfway through this class. Okay, so this is the midpoint. This midpoint is a representative of this class interval. Okay, and then the midpoint for 20 by 24 is equal to 22, and the midpoint for 25 between 29 is 27, and the 32. Okay, another interesting thing, if you add this frequency, it should give, because you had taken the number of occurrences, the 4, 8, 5, 2 and then 1, it should amount to total, the total number of elements. See, the number of elements in the raw data set is total 20. Okay, this is the initial thing you need to set the table. Okay, got the idea? The next we move on to relative frequency. How to calculate the relative frequency? Relative frequency is nothing but the frequency divided by the total frequency. So what is the frequency, relative frequency? 4 divided by 20. 4 divided by 20 is 0.2. 0.2. It is 20%. Okay. So what's like that? First, let us see to calculate the relative frequency, and then see why we. So what exactly we can get the meaning out of that one. Okay. And next one is 8 divided by 20. 8 divided by 20 is 0.4. This is 40%. The 40% of this one. Okay. Next is 5 divided by 20. 5 divided by 20 is 0.25. 0.25. This is nothing but 25%. Okay. Next, 2 divided by 20. 2 divided by 20, how much? It is 0.1. Is 10%. and then 1 divided by 20. 1 divided by 20 is equal to 0.05. 0.05 is equal to just 5%. Okay? So, that is how you can calculate the relative frequency. Okay? So, what do you mean by the relative frequency? If you randomly pick any number between 15 and 19, so there is a 40%, the probability of picking that number between 15 and 19 including 19 is 0.4 probability, means 40% chance you can pick this number. If you pick this number, that is what the meaning it gives. Okay? If you take the relative frequency is 10%, the number between 25 to 29, you can pick those numbers from this raw data is the 10% chance is there. That is what the meaning of relative frequency. Okay? So, next one is the cumulative frequency. Cumulative frequency is the running total of all frequencies. Running total means the first class interval is 4, the second class interval is 4 plus 8, that is 12, and then the third class interval, the cumulative frequency, because it is adding from the previous classes. Okay, 12 plus 5 is equal to 17, and then the fourth class interval, this is 17 plus 2, it is 19, and the final one, it is the 20. The cumulative frequency for your last class interval should be equal to the total number of frequencies, total frequencies. Here, what is the total frequency is 20. What is the last frequency, the cumulative frequency for this class interval between 30 and 34? It is 20. Okay, this is the frequency distribution table. This is how we have calculated. First, you have to take the range, you have to take the number of classes, get the class width, group it, and then take the frequency, take the midpoint, and calculate the relative frequency and calculate the cumulative frequency. These are all the basics for constructing a reasonably good frequency distribution table. Now, you can get some meaning out of this frequency distribution table, how the data can be grouped and how many numbers are there, and then the class midpoint, and then what is the probability of picking up this, and what is the probability of picking the number from here to here, that is from the cumulative frequency we can get. So that is how we can do it. So, that is all about constructing the frequency distribution table. Okay? Got the idea? Okay. Yep. So, once after constructing this frequency distribution table, so let us see how this data can be mapped into some graph. Okay. So, so that we can get some more visual view of this data. Now, it is a group data, how we can get more visual view of this data. So, we can use the graph. One of the most widely used types of graph for representing this frequency distribution is the histogram. Okay? Histograms is series of contiguous bars or rectangles that represents the frequency of data in the given class interval. So, it is a series of rectangular bars, the contiguous bars or the rectangles which represent this each class interval. Class intervals are used along the horizontal axis and are normally equal, and the height of the bar or the rectangle represents the frequency of a given class interval. Frequency means how many times the numbers in this group appears in the raw data group, that is the frequency. Let us draw a frequency, let us draw a simple histogram out of this frequency distribution table. Okay? First, you have to take the y-axis, this is x-axis. Okay? So, here what happens? The class interval, you need to class interval. What this exactly this class interval represents the audit time in date. Audit time in days. Okay, and the y-axis we need to say is the frequency. Frequency means occurrences. Occurrences. Okay, frequency is occurrences. Okay, so we have 5 class intervals. We have 5 class intervals. We can take the width of this class and then represent that bar here. Okay, let us say this is 0, the maximum frequency is 8, 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Okay, so let us represent the first class interval, it is from 10 to 14. So how many, what is the, this is 10 to 14, let us take this width. Okay, so we'll, since we have got the equal width, so let us take equal width and then we'll represent how it looks like. The height means till 4, that is the frequency for this class interval. Let us write like this. Okay, this class interval in between 10 and 14, this represents this is the frequency. Similarly, for 15 to 19, so 15 to 19, this is 8. This is 8, this is 10, this is 10, 14, 10 to 14, this is 15 to 19, 8. Similarly, for 20 to 24, it is 5, this 5 is here. To 24. You got the idea? This is the first class interval, second class interval, the frequency is 8. The third class interval, the frequency is 5. In the fourth class interval, the frequency is 2. Where is 2? Two is here. This is 25 to 29. Okay, and the thing is, the last frequency interval is 1. This is 1. to 34. This is how you can use the frequency distribution. This is okay. This is the frequency distribution. The first class interval, second class interval, the third class interval, the fourth class interval, and the fifth class interval. So it gives. So what we can get to know from this histogram is so. Okay, got the idea. From this frequency distribution table, we have generated this histogram for the raw data. So earlier you just look at how we have transform that a group of raw data, it was just the 20 elements is given and taken randomly and then is put it, and how we have generated frequency distribution table out of that raw data and then turn out to be a group data. So, so these are all the 5 groups we made, and then we calculated frequency, class, midpoint, relative frequency and the cumulative frequency. And with this, so we have created the histogram. It is one of the most widely used graph for representing the frequency distribution table. So looking at this histogram, at least the researcher or the managers so can get to know the how data should look like, how the data under investigation, it is looks like it is how the spread is, and then how the shape. Basically, the shape normally we can, looking at the histogram, we need to compare it with the bell-shaped curve. Most widely used the distribution is this bell-shaped curve. This is from the normal distribution. Normal distribution we compare it with, and comparatively how this shape is, and then after the careful analysis of this one, and we derive some meaning out of that one, looking at the shape. For that purpose, we have generated this histogram. The histogram for this quantitative data is the most widely used graph. There are many other terminologies related with this histogram. Let us discuss whenever it is required. This right now, how from raw data to get the group data in the form of frequency distribution table, and then to write the histogram. Okay, got the idea? Okay, so this is for the quantitative thing. So other charts normally we use is the pie chart. Pie chart or the bar graph, bar chart, and another one very popular in this Pareto chart. And these three charts are for qualitative data. Qualitative means it is a nominal or ordinal. So now you recall from our last session, so the basic measurements in the data in the data measurement. Okay, the first two are nominal and then ordinal, that is the qualitative data, and another one is the interval and the ratio data, that is the quantitative data. The histogram is with respect to quantitative data, and for the qualitative data we use the pie chart, and then we use the basically for this qualitative data is for classification or the identification. How the pie chart should look like, and you can see the pie chart should look like this. This is the complete circle, and then we are dividing based on certain category. This is the pie chart. This will tell some percentage, and this is some portion. The portion of this one, this is another, this X percent probably, this is Y percent, this is Z percent, this is A percent kind of a things. It looks like this because it represents some of the classification thing. And another one is the bar chart. Bar chart, it is in the horizontal time. This will look like, should look like bar chart. Basically, it looks like this. Okay, these are all some of the classification elements you get, and each what is the percent. This is also some X percentage. This is Y percentage, and then this is Z percentage kind of things. The another one is the Pareto chart. Pareto chart is also like the histogram, but we use that in a Pareto rule says 80-20 rule, and normally in the quality control we use it in order to investigate. So how some of the 20% of the element is influencing the other 80% of the element. That theory is there. For that we use the Pareto graph. This is about the frequency distribution table, and then how we can get the histogram out of this. Okay, so let us have a quick recap on this one. First, the raw data. Raw data is ungrouped data. We don't get any meaning out of that one, and then we need to convert that raw data into group data. One of the most widely used thing is the frequency distribution. In the frequency distribution, what we have to do, we have to group the data. What are all the basic steps? One is, first thing is you need to determine the range. The second thing is you need to determine the class from the range to the number of classes, and then you need to determine the width of the class. Once you know the width of the class, you need to determine what is the starting point and ending point for this group, and then how many classes we can have, the class interval, and from that the occurrences, the midpoint basically representative factor of each class interval, the relative frequency relative frequency tells. So, what is the probability of picking any number between this and that, and the cumulative frequency, it's a running frequency, and the running frequency, and that is the basic elements in any frequency distribution table. And from that table, we can get this histogram. It's the most widely and most popular choice for the analyst to draw the histogram out of this to get to know certain shape and certain distribution about the data. This is with respect to charts. Okay, so we can get some basic idea about the data, some raw data to group data, some of the pictorial representation of this data, but it is not enough. Okay, guys, just by having this we cannot get the complete understanding about the data. Okay, we need certain numerical measures to get the complete meaning about complete characteristics of this data set. Okay, so those numerical measures are the measures of central tendency, means the measures of variability, and the measures of shapes. Looking at this one, this is with respect to this, basically the measures of shape. The measure of central tendency talks about the middle portion of the data once you arrange this, and the measure of variability talks about the spread of the data, how data has been distributed from the central point, and then shape of the data, it measures the distribution of the shape of the data. In our next session, let us discuss in detail about this, the numerical measure or the statistical measure. Along with this, how we can use the numerical measure to get the complete understanding of the data set. Okay, got the idea?